Hello, and this is, well, probably not a quick video, but a relatively quick one. So I've been trying to design for quite a while now a DC replacement board for the TI99 4A. I've done other videos on this, and I've kind of been iterating through versions. I've been trying to make it as cheap as possible, but yeah, I've not really succeeded. And so this version is a little bit more expensive than I like. It's not terrible, but it's still more expensive than I like. But yeah, if you don't know the story, the TI99 4A, it uses an AC power supply, which, yeah, they tend to die quite regularly, and they're hard to replace. But internally, the machine has got this power board which has all of the AC conversion stuff and then all the DC outputs, and it's very modular. So my decision was to make a DC power board. Get that in frame. Come on, where are we? There we are. A DC power board that had all the same dimensions and screw holes and positions of stuff, so that it could just be dropped in place and take a DC power source, a nice, fairly readily, easily available DC power source. There's slight caveats because in the TI99, the power switch and the light, they actually come out the front, so they've got to be in exactly the right place. But yeah, we've kind of done that with this. This seems to all match up. And I guess what the idea is that you'll be able to take out the original board, and you can reclaim certain bits like the power switch and the Molex connectors and things like that if you want to, and you can just drop this in its place. So you could undo what you've done if you really wanted to put it back to being back to stock without any kind of real big modifications. So yeah, originally I was trying to do this using normal regulators, these things, which wasn't a great plan, I will admit. But the big thing with these are, come on camera, why can't I find you? Camera's there we are. Yeah, but the thing with these are they're really cheap, they're pence to buy, but you have to do quite a lot of circuitry to get a negative voltage out of it, or stick loads of AC on the board, which I did toy with doing, but kind of defeats the purpose, really. So instead I've gone with the slightly more expensive and slightly more modern, like V style. It's probably too dark. It doesn't matter. Yeah, so these V style voltage regulators, they're drop-in replacements for those, but they can also do negative voltages internally, so you can just get a negative voltage out without having to have a negative voltage in, which is pretty cool. So I've got 3 styles of these. I have got the way the markings work is the same as these voltage regulators. So you have like that's 7805. The 8 means that it's a positive voltage. The 05 means it's 5 volts. And so they have similar things, but they're basically the same. So this is V7812. So you can basically ignore the 8, but it's a 12 volt one. And then I've got 2 V7805s, which are the 5 volt ones. One will be used for minus, one will be used for plus. Technically, you could get both out of one, but I decided to go with 2 instead. I don't remember why. I'm sure there was a reason. Possibly the fact I'm not great at circuit design. I am really just an enthusiastic amateur, if I'm honest. Someone will be able to design this board better. Once I get this working, this will all be open source and freely available. If someone wants to literally just take the board where I've done all the work of matching stuff up and then just drop their own design on there to make it better, they're fully able to do that, and as long as they share it with the rest of the community, that's absolutely fine. So what do we need? Well, we need these, obviously the voltage regulators. We need some capacitors. There's 6 capacitors. They're all 10 microfarad. It says 50 volt, but honestly 25 and above is fine. Yeah, we need our various Molexes, a connector for the power source, some DC in. Our LED, it's red on the original one, but doesn't have to be. You don't need to keep it red if you don't want to. And a 220 UF resistor to protect the LED from having too much voltage stuffed up it. So yeah, so I guess we just start soldering this stuff in. Back in a sec. Just have to make sure we get these things in the right place. Yeah, that's the 12, so the 12 goes here, and after that it doesn't matter. Oh, you see, immediately that was the wrong way around, I think. Is that right? I need to verify that was correct, but I'm pretty sure that's the right way right now. Anyway, yeah, I'll be back in a sec. Right, it's all soldered in place. So we've also put a wire here because, in lieu of a switch, because soldering switches, or in fact unsoldering switches, is annoying. And I put on a couple of power wires I connect to my bench power supply. This is all, I suspect, fairly trivial because I think I've found a short on the board which I'm going to have to track down. So what's probably going to happen is we're going to turn this on and something here is going to explode. Possibly these expensive things, potentially a capacitor. We don't really know till we try. May as well try. I mean, yes, the sensible thing is probably don't blow up the expensive components if you can help it, but I mean, we won't know until we try, right? Right, that's set to 12 volts. Let's turn up our bench power supply to, let's say 13 for now. It will current limit to a degree, so things shouldn't just explode immediately. It will set our multimeter to voltages so we can actually see what's happening. Right, well, I mean, you know, might as well just turn it on. Oh yeah, not even a light, and immediately we've gone down to, yeah, nothing. Not surprising. Okay. Well, annoying. So we need to kind of work out the capacitors on this side that have got the problem. If we just unsolder them, take off all the capacitors on the output side. Okay, so I end up removing all the capacitors, and I think the problem is that I've just made those capacitors far too small for the type I'm using. Fine, so board revision to make them bigger, and I can just get smaller capacitors, but they don't need to be 50 volts, they can be 25, I'm not sure I can get 10 microfarad capacitors that small, but either way, oddly though, it appears to be working, which is not what I was expecting to happen when there's no capacitors in there. They're just there for smoothing though, so yeah. So anyway, so we put our black probe on the ground here, and then if we touch it on the +5, we do have 5 volts, and then the 12 volts, so 12 volts, and -5 volts. Yeah, and you can see also the light. Can you see that? Get a shadow over it, maybe. There you go, the light is on as well. Okay, that threw me a little bit. I assumed this would be an end of project thing, well, end of this version of it. But we are getting the voltages we need, which is intriguing. So what we're going to do, in fact I can't, flux, there we go. So, well, yeah, what we're going to do then is we're going to get a TI99 out and shove this in. I don't have a video cable for TI99, so I have to remember which pins to stick my painted bit of metal connector into. But other than that, let's just make sure it powers stuff. Right, back in a bit. Okay, so this is, let's zoom out a little bit actually. Yeah, this is a TI99. This here is the AC DC board. So if we just unscrew this, that's it. Yeah, there we go. There we are. So this is our fairly complex board. So over here we have all the bits with the AC, and then there's some deep. No, over here we have some AC bits here, so the coil and stuff, lots of things for dropping that AC voltage to DC. And over here is the board that takes the DC away into the computer. There's the switch. Yeah, I've got one over there actually for that. And there's the LED. They use a little shrink wrap over the LED, which is a really good idea, and what I should do on the final thing that I make. So yeah, so what we'll do is we will take this off, and we're going to just verify that. Okay, there we go. We'll just verify that. Yeah, to remove this, you've actually got to undo quite a lot of the board, quite a lot of the machinery. So we need to take that out. And I think that one's in a bolt. Yeah, we don't have to take that one out. We just have to take that one out. And then we have to kind of feed it through. These are horrible, by the way, these machines, for getting back together. All of the shielding and stuff just gets in the way. There we go. So now we can take that entire board out. Much better. There we go. That's that kind of went in a lot easier after I just said that. So yeah, so let's give ourselves some light again. There we go. So here's our board. So there's all the AC gubbins there, and the DC comes through here, and this is the actual AC power coming in. It all gets filtered through there. So we've got there. Yeah, so there's a 6 volt voltage regulator by looks of it. Possibly higher than that actually, but either way, it's a voltage regulator. And another one there as well. So we need this. I don't think I've got one of this exact dimension, so we're still that. Let's verify the voltages first. So the voltages are, I don't think I'm going to be able to get it clear enough. You know what, I'm going to zoom back in again. So you can just see inside there, maybe just, you can see just inside there. I'm getting this, working out where this is in relation to the camera. You know what, let's just do this. Focus camera, focus. The picture's upside down, so I can't, it's, yeah. Can you just see that? Just in there? I don't know if you can or not. Anyway, so this tells us what the voltages are. So it's +5, ground, 12, -5. We take a look at our board when it's pivoted the same way. We have +5, ground, +12, -5. Right. So there we are. So they are lined up correctly, which is good. Very good. So we'll need to remove that. I've got a switch already, so we can just use the switch. And then we'll plug it in and just see what happens. I still need to work out how to get video out of this, but I'll work that out at the same time. Right, back in a bit. Right, oh, there we go. Come on, show me the board. There we are. There we are. There's the board. Right, so that's in. So in theory now we can connect this up, and that should give the same voltages as we expect to see from the original power supply. They go in. We may have twisted these pins, in which case this might be a bit more harder than I imagined. I really hate these connectors. Come on, go in. There we are. Right, that's in. And obviously there's no power, there's no switch because we've not yet put that on. This is obviously not the final power cable. And there we are, that fits on. Drops into place where the other one was. So we can use the original screws. I think these ones, pretty sure they were these ones. We have to sort the LED out, that's fine. Actually, what we'll do is we will put that other switch in place. We can do a full test then, and we'll probably sort that LED out while we're at it. So let's do that. Right, so there we go. You see that? We have our switch in place. I've tested it, it does indeed turn on and off properly, which is good. And our LED with the shrink wrap to protect the two legs from hitting each other. I also measured it against the other one, so it should be pretty darn close. It's close enough to do its job. So now we can bend over that LED, and it kind of sits inside a little socket at the bottom here. And we can push that in, and then the switch should also go in. Not quite. Come on, switch, there you go. Oh, there we go, that is a switch that is working. Excellent. Right, now we can screw this all back in. And the bigger of the screws goes to the back. This one goes down here. Oh, come on, you're going. There we are. There we are. Right. That's in. The light is pretty much there, I'd say. The switch is absolutely switching. Now we can bring. What about that other? Never mind. I think we lost the screw, but hey. Can we pick this up without undoing everything we've just done? Possibly not. Maybe, hold on. If that wire's going to fit through there, then we will. Annoying. Oh, there we are. It's through. Right. So now, can we pick this board up? We can. So we can run this for a similar path the other power lead went. So out the back here, it's hung up on something. It's hung up on. There we go. I think there's a channel it runs through normally, but that's fine. This is not our permanent solution, so we can mess around. We are missing a screw though. Where did I put that screw? The screw that held this down. I wonder where I put that. No doubt someone will have seen. It would have been too late because I'll either have done it anyway or just done it up without bothering. One of the two. Possibly I've dropped it. It's entirely possible I've dropped that screw. It's not over there, is it? No, because all that stuff was covered up before. Oh, there it is. Found it. It's alright. We're good. And I lost the screwdriver. We're fine. We're there as well with that. So That needs to just go back a little bit. There we go. And there, screwed in. Right, so we can technically hit the light, put this back on just for a bit of precaution. I mean, there's no slightly about it actually, that is quite a bit thicker. Alright, so that's the potential issue there then. So you can print that slightly thinner anyway, and it'll be fine. I think that maybe what's sort of hindering that slightly. That's fine though, it's fine. Right, there's a replace. Now we can slip the little power switchy thing back in. That kind of just fits into a gap there. Unless you drop it, of course. Might be working, I'm not sure, I will admit. Right, anyway, those are connected, they are not hitting anything else metallic. Power is on. Switch is working, yay! Alright, I'll lift this up a bit so you can see. So, alright. And it is drawing a higher ampage when it's on. That's a good sign. We need to get some kind of video on this now though, don't we? Right, let me work that one out and I'll get back. Right, so here we are. Now we don't have a proper cable for this, so we're going to use my painted bits of metal connection method, so which is basically I pull apart an ATX power plug. I've thrown it all. Oh no, here it is. So we rip apart one of these to get the bits of metal out of it. And then we just plug them straight into the back of the contacts. Now, there are 3 potential sources, and I can't remember which one is right. So we've got 3 tries of getting this right. So it doesn't work first time. We won't panic. It might be that it's the wrong one, that's all. So it's obviously get the power up on this screen here. And you'll see when it's turned on, you'll see the ampage here just kind of jump up. So you won't because my arm's in the way. Well, never mind, I can't do about that. Right. So you see the ampage has jumped up and nothing. Okay. So I'll get disheartened. It's one of the other 3 holes, I'm sure. Other 2 holes. Let's try the right hand one. And if it's not that, then it could be the middle one. I think the middle one's less likely though, but we'll see. Alright, let's turn her on. Oh, we got something. Okay. It's black and white. Don't worry about that. It's because we only got 1 cable in. It really needs 3 of them to work properly. But yeah, okay, that's working. There's no smoke. Okay, I'm a little bit excited. There's a couple of issues with the board, but it's working is the point. If we push it. Oh, yeah, there we go. Look at that. Hey! Okay, I'm typing upside down, so. This is quite a good keyboard, on these machines. I haven't properly used one yet, because, I haven't had. Oh, half the keys aren't working. How do I delete? How do you delete? I don't know. It's not important. It's fine. It works. The machine is working. I'm astonished, and it's brilliant. It's been so many iterations of this board to get it right. It still is more expensive than I would like it to be. Those components, they worked out about 40 quid, but that's because I had to order them again from America. A lot of that was postage. The boards are cheap enough. They're about, with delivery, they're about 30 quid to get 10 of them. So 10, maybe 5. But anyway, they're pretty cheap. So it's not terrible. This version, I think, is probably good enough to open up for people to play with now. There are better engineers than me that can make versions of this that will work better, but at least the board size is done, it all fits in and it works and everything, so I'm so happy. Thanks for being here for this, because this genuinely is a thrill to see this running. It's the first time I've seen this little thing run, because obviously I've had no power source. So I'm slightly speechless, I will say. Yeah, okay, I'm really happy. I've got to work out how to delete stuff on this keyboard as well. I mean, there's not even any arrow keys. How do you do that? Anyway, it doesn't matter. It honestly doesn't matter. It's fine. It's working, and that's great. I will. I'll put a link in the bottom to show where these files are stored for the PCB, the components, where you can get them, what they're called, etc., etc., etc. Other than the actual free voltage regulators, everything else is fairly bog standard stuff, which you can get from anywhere. So that's not bad. And obviously, a lot of the stuff you can reclaim from. A lot of the stuff, two things. you can reclaim from the actual TI board, the header and the switch. You could just reclaim from the board. You can find alternatives, obviously, if you want to build a completely fresh board, but I haven't, so I haven't got the model numbers for those. But feel free to experiment. Okay, I'm really happy that worked, and I'm utterly thrilled. I'm going to have a cup of tea and a lie down, I think. Thanks for watching. See you next time.